Hello, students. We're talking about trigonometry. Trigonometry is a really interesting branch of mathematics. And on any scientific calculator, you'll see these buttons. So there's 3 buttons on the calculator, and they actually are what we call trig ratios. They are sine, cosine, and tangent. So any math problems that you see that have these sort of words in them, that's trigonometry. It's the study of right triangles. On calculator buttons, the whole word doesn't fit. So you'll see SIN, sine, COS, cosine, and TAN, tangent. Those are abbreviations, so they fit on the calculator button. The key to understanding trigonometry and where it came from is similar triangles. So here is a triangle, and we're going to play with it a little bit. And we're going to talk about the relationship between the sides and the angle. And we're going to first spend some time with the tangent ratio. So we're going to do a ratio. And the ratio we're going to study right now is the tangent ratio. A ratio of what? We're going to choose, a ratio is a comparison of 2 quantities, usually whole number quantities. So like 3 to 3 is a ratio, and 7 to 7 is a ratio, and 3 to 4 is a ratio, and 1 to 2 is a ratio. So I'm going to look at this special right triangle. We know it's special. And I'm going to ask you, we're going to pay attention to this 45 degrees in the corner. And I'm going to ask you, do we know the ratio of these 2 sides? Do we know how x compares with 3? Do we know what x equals? Yeah, this is a 45, 45, 90 triangle. So these 2 sides are the same. If I wanted to set this up as a ratio, I could say that x over 3. That I can make a fraction out of those 2 side lengths. And I know, because it's a 45, 45, 90 triangle, that those 2 sides have to be the same because it's isosceles. So that means that this side, this opposite side from the angle divided by this one has to equal 1. Okay, let's look at a bigger triangle that is also has a 45 degree angle in the corner. I'm gonna look at this one. I'm just gonna make a bigger triangle right here. It's gonna have the same angle in the corner. And then I'm going to finish the triangle right here. Okay, what kind of triangle is that? What kind of triangle is the blue triangle? Well, it still has 45 degrees in the corner. Let's say it is 5 long. Could I figure out how long this side is? Is it a right triangle still? Sure. Is this triangle still 45, 45? 90? Yeah. So what's the ratio of this side to that, the adjacent side, the side next to the angle? It is also 1. Okay, x divided by 5 has to be 1 because this is 5. 5 divided by 5 is 1. This is 3. 3 divided by 3 is 1. We could do it again. We could make a really, I'm going to use a marker, really big triangle here. Really extend that side. I'm going to extend that side. Now, what angle is this? This is still a 45 degree angle, isn't it? So I still have a really big similar triangle. This triangle is similar to this one, is similar to this one. And all of them are 45, 45, 90. 45, 45, 90, 45, 45, 90. What is the ratio of this side to this side? Even though the triangle is way bigger, let's say that it's 9. Let's say that this leg of the triangle, the one next to the 45-degree angle, let's say it's 9. Could we find how long this opposite one is? Yeah, it's also 9. Okay, so we can write a ratio with that. X over 9 is also going to be 1. Because 9 divided by 9 is 1. And 5 divided by 5 is 1. And 3 divided by 3 is 1. Which means that if I know this angle here is 45, I know that the ratio of the side opposite the angle divided by the side next to the angle is going to be 1. The concept that we're playing with is called the tangent ratio. So the tangent of a 45-degree angle is 1. The tangent of this 45-degree angle is 1. The tangent of that big 45-degree angle, well, all 45-degree angles are 45-degree angles. So it doesn't matter what size triangle you have, the tangent of a 45-degree angle is always going to be 1. All right, so this is how this works. Let's look at the definition of tangent. Nope, we're gonna keep playing. So if you guys have calculators or phones, you want to turn them sideways. You want to make sure they are on the degree mode. If you have a radian mode, you're going to get weird negative answers, and that's not going to work. I have an iPhone, and you turn it sideways, and then you can see the tangent button. And if you do 45 and then hit the tangent button, you'll see that it's 1. What if the angle is not 1? What if I change the size of the angle? How is that going to affect the tangent ratio? So here's a triangle right here. And I'm going to, instead of having a 45, 45, 90 triangle, I'm going to cut it off. We'll still say that this is 3. Okay, but I'm going to cut the triangle here. Maybe here. If I want to find X, what do we know about it? If it's 45 degrees, so I'm looking at this little triangle right here, the blue one. Okay. If this was a 45-degree angle, this side length would be 3. But this angle is a little smaller. It's not 45. How much do you think that is? It's less than 45 now. Should we say it's 35? Okay. Opposite from the 35-degree angle, we have X. Next to the 35-degree angle, we have 3. So if I was going to try to find X over 3, is that going to equal 1? No. Is it going to be more than 1 or less than 1? One thing that we can do, we know that this answer is going to be less than 1. One thing we can do is we can use our calculators and we can see what the tangent of a 35-degree angle is. So we can type 35 and then we can hit the tangent button. Or you can look on a table of values, and I'll put a link to that. Back before they had calculators, they used books with tables in them. And it turns out that it's not going to equal 1. It's going to equal 0.700. It happens to be a really interesting one. Yeah. And how did I know that? I know that because it's going to be less than 1. If it was equal to 1, then this would be 3 and this would be 3. Okay, it turns out that the tangent of a 35-degree angle is 0.7. And then if I wanted to finish solving this, if I wanted to solve this for x, I would multiply 0.7 times 3. 1 times 3 would be 3, but it's not going to be that long. It's going to be 0.7 times 3. So I'm just going to figure it out. Okay. It happens that I think I'll just do it this way. This is 0.7. I'm going to multiply both sides by 3. And we'll practice this a bunch. And this is about 2.1. Is that reasonable? Does it seem like x could be 2.1? Sure. It's less than 3. Let's do another one. Let's see if we can figure this out. We're just playing and exploring. We're thinking about where the tangent ratio came from, what the tangent ratio is, what am I comparing, where are all these numbers coming from. Okay, so let's do a similar process, but let's say we make, instead of a 45-degree angle, let's say we make it bigger. Let's say we change this angle from 45 and we make it that way. And we'll keep the base the same. We'll keep the base as 3. And the question is, so this is the triangle I'm talking about. The base is still going to be 3. And the question is, okay, well, I changed that angle. It's not 45 anymore. It's bigger. How big do you think that angle is? 90 is here. Do you think it's 70? 65? Let's call it 70. I don't have a protractor, so I'm not going to measure it. So now we have a 70-degree angle. And if we had a 45-degree angle, it was like that. If we made it smaller, the distance between my fingers got smaller. Now 45 is like that. If I make it bigger, what happens to the distance between my fingers? What's the relationship between x and 3? It's not 1. It's not 3 and 3 anymore. This side got a lot longer because this angle got bigger. So if you change this angle, it's going to change the relationship between the opposite side and the adjacent side. So instead of doing a 1-to-1 ratio, now it's going to be something to something else. So if I was going to do this problem, I would need to find the tangent of a 70-degree angle. And I could do that with a calculator, or I can do that with other information. What do we know? We know our answer is going to be bigger than 3. A lot bigger than 3? I don't know. So I could type in 70, I could hit tangent, and then I could, so yeah, the tangent of a 70-degree angle is, I looked on the table, is 2, and some people typed it into the chat during class, 7, 4, 7, I'm going to round to 5. Okay. We can look at a trig table online. I put a link. And then if I want to know how long this side is, I'm going to change this to an approximate. Okay, then I can multiply that by 3. And I would get about 8.24. So x is around 8.24. Is that reasonable? Does it seem like it's that long? Maybe my angle wasn't right. It might be 70 might be a little bit bigger. Okay, so this is what we're doing for a while, you guys. We're talking about different relationships inside of right triangles. And what we're focused on is one of the acute angles. So there's no obtuse angles in a right triangle. There's a right angle, and then there's two acute angles. And we are focused on one of the acute angles of a right triangle. Okay. And you are going to, it depends on the problem. Sometimes we want this acute angle and sometimes we want this one. If I am looking at angle A, if angle A is the angle I'm interested in, then I want you to put a star next to it. And I'll be asking you to do this on the final as well. I want you to put a star next to it. And from this angle, we are going to label which leg is opposite. It's all the way through the triangle to the opposite side. We're going to label which leg is next to it. That's called adjacent. And which one's the hypotenuse. The hypotenuse is always the one across from the right angle. Okay, that will be the first step on practice problems we do, and that will be the first step when you get to your final, when you have a problem like this. Tangent, the tangent ratio is defined as taking the leg opposite and dividing it by the leg adjacent. That's just what it is. It's the definition of a tangent. So if you want to write the formula, we're going to write it this way for now. The tangent of an angle is equal to the opposite side, and this is the way that you can write it on the paper, opposite over adjacent. And the more you write that out, the more it'll get in your head. And trig functions do not go away until you are done taking math. So the tangent of an angle is equal to its opposite side divided by its adjacent side. That's the definition. That is the ratio. You want to know what the tangent is, you need to find the opposite side and the adjacent side. Okay, so let's practice. What is the tangent of angle H? So angle H is right here. I'm going to put a star next to angle H. After that, I'm going to label the sides because Ms. Bliss told me to. All right, where is the opposite side? Well, if this is the angle I'm interested in, the opposite side is over here. Which side is next to it? The adjacent side. Well, there's two that are next to it, but one of those is the hypotenuse. How do we know which one's the hypotenuse? The one across from the right angle is the hypotenuse, which means that the other one, the other leg, is called the adjacent side. Okay, so we're trying to write the tangent of angle H. The tangent of any angle, acute angle in a right triangle, is its opposite side divided by its adjacent side. It's a fraction of those two values. So for this math problem, we're going to say the tangent of angle H is equal to, where's the opposite side? It's 12. So I'm going to substitute in 12. And where's the adjacent side? It's 9. That's the answer, 12 over 9. You could just put 12 over 9, and that would be fine. If you want to do a little bit more, you can simplify 12 over 9 because they both have a 3 inside. 12 divided by 3 is 4. And 9 divided by 3 is 3. So you could also do that. Both of these would be perfectly good answers. I would put it all together. You could just say 4 over 3. Some textbooks and online programs would have 4 over 3. But you could also just include the whole thing. The tangent of angle H is 4 over 3. Now, I have a question. Is that angle less than 45 or more than 45? I know that angle H, if it was 45, then this side would be 9, but it's bigger, right? I know that angle H is greater than 45 degrees. You know how, do you see how I know that? I wonder if I could find out how big it is. Interesting. All right, let's practice another one. So this time we want the tangent of angle F. They put a little mark here. I'm going to put a star next to it. This is the angle I'm interested in. And this side is now opposite. So the opposite side is all the way through the triangle. This is the opposite side. Okay. Which one's the hypotenuse and which one's the adjacent? This one's the hypotenuse. The hypotenuse is the longest one. It's also across from the right angle. Okay, and then we have, that's an H, by the way. And we have the last one is the adjacent. Adjacent is, it's next to the angle. It's the leg that's next to the angle we're interested in. Okay, and now I'm going to do the same thing here. I'm going to do the tangent. I'm going to write my formula. The tangent of any angle is its opposite side divided by the adjacent side. And for this angle, we want angle F. And angle F is going to be 9 over 12. And if you want to simplify that, they both have a 3 in them. So this is going to be 3 over 4. That's a good answer. The tangent of angle F is 3 over 4. Simplified. Okay, what do we know about that angle? 45 or less than 45? If it was equal to 45, then both sides would be 12. This angle would be, it would be a perfect 12 and 12, right? But that side's shorter than 12, so I know that angle is less than 45. All right, this is exactly like the type of question I'm going to give you for the final. And I'm going to say solve for x. Okay, maybe I'll have you solve the whole triangle. Maybe I'll just have you solve for x. Here is, we'll be practicing these, but here's how you do this. First, you're going to label the angle that you're interested in. The acute angle that's given to me is 48, so I'm going to put my star over here where I saw the number. Okay, so this is the angle I care about. This is the opposite side. This is the hypotenuse. Okay, and this is the adjacent side. All right, that's the first step. When you get it, when you get your question, the first thing you do is label it. The next thing you're going to do is you're going to use the tangent function. So the tangent of any angle is its opposite side divided by its adjacent side. And for this problem, we know it's a 48-degree angle. Okay, so we're going to substitute that in, 48 degrees. And the numbers I have are x, oh no, I don't know, and 5. From there, I'm going to use a calculator to figure out what a tangent of a 45-degree angle is. And then I need to find x. So I'm going to get x by itself. This says x divided by 5 equals some weird little decimal. I'm going to do multiply both sides by 5. Okay, that's going to get me x by itself. This is a little algebra. So the tangent of 48, just some number. I'll figure out what that is in a second. Okay, that's 1. So the x is going to equal 5 times whatever the tangent of 48 is. Do you think the tangent of 48 is more than 1 or less than 1? And do we think our answer is longer than 5 or shorter than 5? If this was a 45-degree angle, almost the same, right? If this was a 45-degree angle, this would be 5. But it's not a 45-degree, it's a 48-degree angle. Anyone want to look on their calculator and see what 48, the tangent of a 48-degree angle is? And make sure you're on degrees and not radians. Who got it? Okay. 1.11 something. Yeah, that makes sense. It's more than 1 because the angle is bigger than 45. Okay, so the answer is about, multiply, or you can just type this into Desmos and it will tell you the answer. The answer is about 5.55. Does that seem reasonable? Does it seem like this side could be 5.55? Yeah, it does to me. It's longer than 5, so that's good. And it's not much longer than 5 because the triangle we're trying to find is not much longer than the 45, 45, 90. Okay, last one. Plane takes off and climbs at a 12-degree angle. Look, it's my brother. He's a United pilot, kind of furloughed right now. Is that angle sufficient to fly over 11,088 foot mountain that is 12.5 miles from the runway? Or does the plane need to increase its angle of ascent? Does it need to get steeper to get over this mountain? This is a really weird looking picture, but let's do the math problem. Here is the angle that I'm interested in. Here is the opposite side. The plane is traveling on the hypotenuse of this figure. And the 12.5 miles is representing the adjacent side. Okay, so here's how you set this up. We have the opposite and we have the adjacent. We're going to use the tangent ratio. So the tangent of any angle is its opposite side divided by its adjacent side. And for this problem, we have a 12-degree angle. That is a really small angle. I do not think this picture is right. This looks more like, I don't know, 20 to me. We're going to do x over 12.5 miles. Okay, I'm going to multiply both sides by 12.5 miles. And then what that does is that makes the fraction go away and makes me have an x. Okay, that goes to 1. 12.5 miles divided by 12.5 miles is 1. So this is equal to x. Okay, and then I'm going to get a table of values, or in my calculator, I'm going to type in the tangent of 12. What is the tangent of 12? I'm going to come do more work over here. So I'm 12.5 miles times whatever decimal we find out. I'm going to use a calculator because I don't have the table pulled up. And again, for a lot of phone calculators, you have to turn them sideways so that the scientific portion shows up. Okay, and then I'm going to hit tangent, and it is 0.212126 maybe. And that will tell me approximately how high that plane will be, and then we can check and see if it's will clear the mountain. So I'm going to multiply that by 12.5. Try again. 12 tangent. Using calculators can be tricky if you're not used to them, especially because there's a bunch of different types. And especially since I'm getting a text message right now. All right. We got 2.6569 miles. Okay. Is that, how do we find out if that's 11,088 feet? Is 2.5 miles more than 11,000 feet? I don't know. Let's, anyone know how many feet in a mile? 5,280. So if I want to find out how many feet that is, I'm going to multiply by 5,280. And I get, so I'm going to take that and I'm going to multiply by 5,280 because there are 5,280 feet in each mile. Okay, so that's 14,028 feet. 0.73. Okay. So the plane after 12.5 miles at this incline, this angle of, you know, taking off is 14,000 feet. Is that enough to clear the mountain range if the mountain is 11,000 feet? Yes. So is it sufficient? Is that angle sufficient? Or does the plane need to increase its angle of ascent? Yes, it is sufficient. No, it does not need to increase. Yes, sufficient. No, it does not need to increase the angle of ascent. Okay, that's the answer. That's the answer to this problem. Fun times with trig. All right, be good, work hard, keep learning. I will see you soon.